Between 1805 and 1880, American carpenters built approximately 14,000 covered bridges across the country. Roughly 1,500 of them used zero iron, zero bolts, zero plates, zero fasteners of any kind. The trusses were held together by through-pegged mortise and tenon joinery, the same method medieval European timber framers had used for 600 years. 880 covered bridges still survive in the United States today. Some of the pure wood examples are outlasting the iron-bolted ones built 50 years later. The American covered bridge era ran roughly from 1805 to 1880. The first major American covered bridge was the permanent bridge across the Schuylkill River at Philadelphia, completed in 1805 by Timothy Palmer of Newburyport, Massachusetts. The permanent bridge was 550 feet long, 3 spans, with a wooden truss carrying a road deck. Palmer originally built it as an open bridge, but the city of Philadelphia paid for a wooden roof and siding to be added in 1806 to protect the trusses from weather. That roof is the reason the bridge survived as long as it did. The trusses, sheltered from rain and sun, lasted for more than 70 years before the bridge was replaced. The covered design, born almost accidentally as a roofing modification on a previously open bridge, became the standard American wooden bridge style for the next 75 years. Why cover the bridge at all? The answer is preservation. Wooden trusses exposed to weather rot. The combination of rain soaking the wood, sun drying it out, and winter freeze-thaw cycles, cracking it apart, kills an exposed wooden bridge in 20 to 25 years. A wooden bridge with a roof and siding protected from direct weather contact will last for 100 years or more. The economics were simple. The roof and siding added about 10% to the original construction cost. The roof and siding extended the service life by 4 to 5 times. The math worked. By the 1820s, American bridge engineers had concluded that covering the wooden bridge was the standard practice, not an optional add-on. From that point forward, almost every major wooden bridge built in the United States was a covered bridge. The truss systems used in American covered bridges between 1805 and 1880 fell into several distinct patent families. Theodore Burr of Vermont patented his Burr arch truss in 1817. The Burr arch combined a wooden arch with a multiple king-post truss, using the arch for primary load-bearing and the truss for stiffness. The Burr arch became the most common American covered bridge truss type for medium-span construction. Ithieltown of Connecticut patented his town lattice truss in 1820. The town lattice was a series of crossed wooden planks at 60-degree angles, forming a continuous lattice structure that distributed loads through the whole truss rather than concentrating them at specific joints. The town lattice was cheaper to build than the Burr arch and could be assembled by less skilled carpenters. It became the dominant truss type for cheaper short-span bridges across rural America. Stephen Harriman Long, a United States Army topographical engineers officer, patented his long truss in 1830. The long truss was a paneled king-post truss with diagonal counterbraces, optimized for shorter spans. William Howe of Massachusetts patented his Howe truss in 1840. The Howe truss combined wooden compression members with iron tension rods, technically violating the zero-iron rule of the older pure wood tradition. But the Howe truss became the standard for railroad bridges through the 1860s and 1870s because the iron tension rods made the truss substantially stronger than the pure wood alternatives. If you appreciate the depth of these American industrial heritage stories and want to support more of them, join at the Boss tier for early access and members-only polls, or Final Boss for member shoutouts and members-only videos. The link is in the description below. Now we walk through what pure wood truss construction actually looked like in practice, and why approximately 1,500 American covered bridges were built without a single piece of iron. The economics of covered bridge construction in the rural 1820s through 1880s American economy followed a particular logic that explains why the pure wood form became dominant. A typical covered bridge of approximately 150 feet length cost the local rural community approximately $2,000 to $3,000 in mid-19th century currency. The cost included the timber, the labor of the master carpenter crew, the foundation's stone masonry, and the roof and siding materials. The bridge was typically funded by a county or township road appropriation, supplemented by tolls collected from users for several years after opening to repay the construction debt. The covered bridge form was specifically chosen by rural communities because it required no specialized materials beyond what could be sourced locally, no specialized labor beyond what could be hired from regional master carpenters, and no maintenance investment beyond periodic re-roofing and routine carpentry repairs. The economic comparison with iron-bolted bridges of the same period favored the pure wood form substantially. An iron-bolted covered bridge of equivalent span typically cost 40 to 60% more than the pure wood equivalent, because the iron components had to be manufactured at a centralized foundry and shipped to the construction site. The shipping costs alone for iron components could double the bridge construction cost in rural areas distant from rail and water transportation. The pure wood bridges had no shipping cost for the major structural materials because the timber was sourced locally. The cost advantage of the pure wood form was particularly significant in the years before the American railroad expansion of the 1850s, when overland transportation of heavy iron components could cost as much as the iron itself. The local economic effect of covered bridge construction on rural communities was substantial. A typical covered bridge construction project employed approximately 20 to 40 workers for 3 to 6 months, generating wages of approximately $10,000 to $20,000 per project in the local economy. The bridge construction crews typically lodged with local families and ate at local taverns, distributing additional spending throughout the community. The completed bridge then enabled commerce that had been impossible before, with farm products from the community being able to reach broader markets via the road network that the bridge enabled. The aggregate economic effect of covered bridge construction on rural American economic development between 1805 and 1880 has been estimated by economic historians at approximately 1 to 2% of total rural American gross domestic product per year during the peak construction period of the 1830s through the 1850s. Pure wood construction relied on a specific tradition of carpenter craftsmanship inherited from medieval European timber framing. The key technique was through pegged mortise and tenon joinery. A mortise is a rectangular hole cut into one timber. A tenon is a rectangular projection cut on the end of another timber to fit exactly into the mortise. When two timbers meet at a joint, the tenon of one slides into the mortise of the other. To lock the joint, the carpenter drills a perpendicular hole through both timbers at the joint, then drives a wooden peg, called a trunnel, through the hole. The trunnel is typically made from a hardwood like oak or hickory, slightly larger in diameter than the bore, and driven home with a wooden maul. As the trunnel is driven, it compresses the wood around it, creating a friction-locked joint that holds the two timbers together as long as the trunnel and the surrounding wood remain intact. No nails, no bolts, no glue, just wood-on-wood mechanical lock. The tools used to build a pure wood truss were the standard medieval timber framing tools that European carpenters had used since the 12th century. The ship auger was a long-handled wood-boring tool, hand-cranked, that could bore through holes up to 2 inches in diameter through a beam over a foot thick. The slick was a long-handled chisel with a flat blade up to 4 inches wide, used to clean out mortise holes after they had been roughly chopped with a smaller chisel. The framing square was a large carpenter square, often 2 feet by 3 feet, used to lay out the geometry of the joints. The beetle maul was a heavy wooden mallet, often 6 to 10 pounds, used to drive trunnels home. The crosscut saw, ripsaw, broadaxe, adze, and froe completed the basic tool set. Almost all of these tools were available in any American village by the early 1800s, and most rural carpenters owned them as part of their working trade kit. The construction process for a pure wood-covered bridge typically took 3 to 6 months from groundbreaking to opening. The crew was usually 6 to 12 men, including a master carpenter who managed the work, 2 to 4 journeyman carpenters who did the skilled framing, 2 to 3 laborers who handled materials and rough work, and a teamster with an ox team for hauling heavy timbers. The timber was felled locally in most cases, with the wood selected from straight-grain trees of appropriate species. Eastern hemlock and white pine were the dominant species in New England covered bridges. Oak was used for the longest spans and for the trunnels. Spruce and tamarack were used in northern New England and the Adirondacks. Yellow pine was used in southern covered bridges. The local forest typically provided enough timber for a bridge within a few miles of the construction site, reducing transportation costs to almost nothing. If you are new here and enjoying this kind of historical depth, subscribe so you do not miss the next video. We publish 2 videos per day this week. Now we walk through the specific named bridges and the master carpenters who built them. Theodore Burr of Vermont was probably the most prolific American covered bridge engineer of the early 19th century. Burr was born in Torringford, Connecticut in 1771 and apprenticed under his uncle as a master carpenter in the 1790s. He moved to Oxford, New York around 1800 and began designing and supervising bridge construction in central New York State. He patented his Burr arch truss in 1817, but he had been using the design since approximately 1804. Burr personally supervised the construction of dozens of major covered bridges across New York, Pennsylvania, and the Ohio Valley between 1805 and his death in 1822. His largest bridge was the McCall's Ferry Bridge across the Susquehanna River in Pennsylvania, a single arch span of 360 feet, completed in 1815. The McCall's Ferry Bridge stood for only 3 years before being destroyed by an ice flood in 1818, but during those 3 years, it was the longest single-span covered bridge in the world. Burr's other major works included covered bridges at Trenton, New Jersey, Easton, Pennsylvania, Catskill, New York, and Harrisburg, Pennsylvania. Few of his original bridges survive today, but his arch truss design lived on. Builders across the eastern United States used the Burr arch on thousands of bridges in the 1820s through the 1870s. Ithiel Town of Connecticut was the other major American covered bridge engineer of the early 19th century. Town was born in Thompson, Connecticut in 1784. Unlike Burr, who came from a carpenter tradition, Town was trained as an architect. He studied under Asher Benjamin in Boston in the 18-teens and developed an architecture practice in New Haven, Connecticut. The Town lattice truss, patented in 1820, was deliberately designed to be cheap to build. Town licensed the truss design widely, charging $1 per foot of bridge span, built using his patent. He made enough money on the licensing to retire from active bridge engineering by the 1830s, focusing afterward on his architecture practice and on his personal library of engineering and architecture books, which became one of the largest private libraries in 19th century America. Town's lattice truss became the most widely built American covered bridge type because it was the cheapest. A rural carpenter could build a Town lattice covered bridge with no special training in timber framing beyond the standard carpenter's tools. The lattice was assembled flat on the ground, then raised into position using gin poles and block and tackle systems. The purewood Lewis Wernwag bridges deserve special mention as the technical pinnacle of American zero-iron covered bridge construction. Lewis Wernwag was a German immigrant carpenter who arrived in the United States in 1786 and settled in Philadelphia. He spent his career building bridges across the Schuylkill, Delaware, and Susquehanna River systems. His most famous work was the Colossus of Fairmount, a single arc-covered bridge across the Schuylkill River at Fairmount, Philadelphia, completed in 1812. The Colossus had a single wooden arch span of 340 feet, the longest single-span wooden bridge in the world at the time. The Colossus used zero iron in its truss construction. The arch was built up from individual laminated wooden members, each piece fitted by mortise and tenon and locked with trunnels. The bridge carried road traffic for 30 years before being destroyed by fire in 1838. Wernwag built dozens of other major covered bridges across the eastern United States, including the Economy Bridge across the Allegheny River and the Pittsburgh Bridge across the Monongahela. None of his original bridges survive today. His pure wood arch engineering, however, influenced the entire subsequent American covered bridge tradition. Beyond the master engineers and the patent families, the covered bridge era produced a generation of regional master carpenters whose names deserve recognition. In Vermont, the Hewitt family of West Glover supervised the construction of more than 40 covered bridges across northern Vermont between 1840 and 1875. In New Hampshire, James Tasker of Cornish built approximately 80 covered bridges across New Hampshire and Vermont before his death in 1903. In Pennsylvania, the Lockman family of Lancaster County built more than 60 covered bridges across the Susquehanna and Schuylkill watersheds. In Ohio, John Brubaker of Dayton built approximately 90 covered bridges across central Ohio between 1845 and 1875. In Indiana, J.J. Daniels of Putnam County built more than 60 covered bridges across central Indiana between 1855 and 1890. Most of these regional master carpenters trained apprentices who continued the work. Most of their original bridges are gone. A few survive. The Tasker bridges in Cornish and Walpole are mostly still in service. The Daniels bridges in Putnam and Park counties are mostly still in service. The Brubaker bridges in central Ohio are mostly gone, replaced by concrete and steel highway bridges in the 20th century. The covered bridge construction tradition also produced specialized regional truss variants that adapted the major patent designs to local conditions. The Vermont lattice variant of the town truss used heavier lattice members and tighter spacing for the heavier winter snow loads of northern New England. The Pennsylvania burr arch variant used a flatter arch profile better suited to the narrower river valleys of the Pennsylvania Ridge Country. The Ohio Smith truss, designed by Robert W. Smith of Toledo, Ohio, used a panel and strut configuration optimized for the relatively flat agricultural country of Ohio and Indiana. The Wernwag arch variant used in southern Pennsylvania and Maryland was a heavier and shorter version of the original Lewis Wernwag laminated arch, optimized for shorter spans across smaller streams. Each regional variant represented a slight technical adaptation to local conditions, accumulated through decades of master carpenter experience. The variants are documented in the Historic American Engineering Record Survey of American Covered Bridges, compiled by the National Park Service between 1965 and 1980. The survey identified approximately 23 distinct regional truss variants used in American covered bridge construction between 1805 and 1880, all derived from the four major patent families, but adapted to specific regional engineering and economic conditions. The covered bridge as a cultural institution in 19th century rural America was a community gathering place beyond just a transportation structure. The covered interior provided shelter from rain and snow. The sides of the bridge interior often carried advertisements, political posters, and community notices. The Vermont covered bridge interior advertisements of the 1850s through 1880s are documented in regional historical archives. Patent medicine advertisements, lecture notices, livestock sale announcements, election handbills, and church meeting notices all appeared on the interior sidewalls of covered bridges across the rural Northeast. Some bridges had small benches built into the interior siding for travelers to rest. Some had small lookout windows cut into the siding to admire the view. Some had small interior compartments where the bridge attendant could store tools for snow removal and minor repairs. The covered bridge interior was a small, enclosed public space in the largely open landscape of rural America. The bridges had social functions beyond their transportation purpose. That social function ended with the abandonment of most covered bridges in the early 20th century. The surviving bridges are mostly empty interiors today, with the advertising posters and bench seats long since removed. The Cornish-Windsor Bridge between Cornish, New Hampshire and Windsor, Vermont is the longest covered bridge still in service in the United States today. It is a town lattice truss-covered bridge, 449 feet long, crossing the Connecticut River. It was built in 1866 by Bella J. Fletcher and James F. Tasker, two New Hampshire master carpenters who specialized in town lattice construction. The bridge replaced an earlier covered bridge at the same site that had been destroyed by ice in 1865. The Cornish-Windsor Bridge carries automobile traffic today and is on the National Register of Historic Places. The original town lattice truss is the same wood that Fletcher and Tasker installed in 1866, with periodic replacement of individual lattice members as they have aged out. The total replacement count over the bridge's 159-year service life is approximately 15% of the original truss members. 85% of the wood you walk over when you cross the Cornish-Windsor Bridge today is the same wood that the bridge opened with in 1866. The reason pure wood-covered bridges have outlasted many iron-bolted equivalents is a quirk of materials science that the 1820s wall builders intuited without being able to explain it formally. Iron in contact with wood in a moist environment, even an indoor environment like a covered bridge interior, accelerates wood decay. The chemistry involves galvanic corrosion of the iron releasing iron oxides into the surrounding wood, combined with the iron acting as a thermal bridge that pulls moisture into adjacent wood through condensation cycles. Pure wood joints, by contrast, allow the wood members to expand and contract together through humidity cycles, and the trunnel and mortise mechanical lock self-tightens slightly as the surrounding wood swells with moisture. The iron-bolted equivalents tend to develop loose joints over time as the iron stays the same dimension while the surrounding wood swells and shrinks seasonally. The pure wood Howe-style trusses with iron tension rods can develop iron stress cracking in the surrounding wood that progresses faster than pure wood decay would. The 1820s master carpenters did not know any of this in formal materials science terms, but they knew from observation that iron in wood was a problem. They built the pure wood bridges accordingly. Anyone who has seen the masonry on a 150-year-old bridge knows this. The American covered bridge era was a particular conjunction of available technology, available materials, available labor, and economic logic. Wood was abundant. Carpenters were skilled. Iron was expensive. Roads were rural. Spans were short. The covered bridge fit those conditions exactly. As the conditions changed in the late 19th century, the covered bridge era ended. Iron and steel became cheap. Wood became expensive as the eastern forests were depleted. Railroad bridges needed to carry heavier loads than wooden trusses could handle. Roads were paved and standardized. The covered bridge stopped being built. The last major American covered bridges were built in the 1880s. By 1900, the era was over. The covered bridge construction tradition extended beyond the United States into Canada, particularly in the province of New Brunswick and Quebec, where similar climatic conditions and similar rural economic patterns produced extensive covered bridge networks. New Brunswick alone had approximately 340 covered bridges at peak construction, with approximately 60 surviving today. The Heartland Covered Bridge in New Brunswick, completed in 1901, is the longest covered bridge in the world at 1,282 feet across the St. John River. The Heartland Bridge is a 7-span timber truss covered structure, built using construction methods substantially derived from the earlier American covered bridge tradition. The Canadian covered bridges represent the tail end of the broader North American covered bridge tradition, with the latest examples in New Brunswick built as late as the 1940s, before the form was finally displaced by modern materials. The European technical roots of the American covered bridge tradition deserve acknowledgement. The medieval European timber framing tradition that produced the mortise and tenon joinery techniques used in American covered bridges traces back to the 12th and 13th centuries. The Transestack master carpenters developed sophisticated timber-framed construction for cathedrals, manor houses, and bridges across the British Isles, the Low Countries, the German states, and Scandinavia. Specific covered bridge precedents existed in Europe well before the American tradition, including the Koppelbrücke in Lucerne, Switzerland, built in the 4th century, the Holzbrücke at Rapperswil, Switzerland, from the 15th century, and various smaller covered bridges across the Alpine regions. The American immigrants who built the early American covered bridges of the 1805s through the 1820s brought this European timber framing tradition with them. Theodore Burr, Ithieltown, and Louis Wernwag all drew on European timber framing precedents in developing their American patent designs. The covered bridge preservation movement that began in the 1920s has played a crucial role in the survival of the remaining American covered bridges. The earliest preservation efforts came from regional historical societies in Vermont, New Hampshire, and Pennsylvania, which organized local funding to maintain individual covered bridges as the state and county governments cut their road maintenance budgets during the Great Depression. The National Park Service began surveying American covered bridges in the 1930s through the Historic American Engineering Record Program, producing systematic dissections of approximately 1,200 covered bridges across the country. The National Society for the Preservation of Covered Bridges was founded in 1950 as a national organization specifically focused on covered bridge preservation. The Society has been the leading institutional force behind covered bridge restoration work for the past 75 years. Approximately 880 covered bridges survive in the United States today. The largest concentrations are in Vermont, with about 100 surviving bridges, Pennsylvania with about 200, Ohio with about 140, Indiana with about 90, and New Hampshire with about 50. The remaining surviving bridges are scattered across other northeastern, midwestern, and rural southern states. Maine, Massachusetts, Connecticut, New York, Maryland, Virginia, West Virginia, Kentucky, Tennessee, North Carolina, and Georgia all have at least a few surviving examples. Oregon has approximately 50 surviving covered bridges, the only major western state with significant survivors. The Oregon covered bridges were built by Pacific Northwest carpenters between the 1850s and the 1920s, using a longer, pure wood tradition that extended further into the 20th century than the eastern equivalents, because Oregon was settled later. The covered bridge restoration movement that began in the 1950s has preserved most of the surviving structures. Local historical societies, state preservation offices, and the National Society for the Preservation of Covered Bridges have funded inspection, repair, and rebuilding of hundreds of covered bridges across the United States over the past 70 years. The work follows traditional methods where possible, using the same mortise and tenon joinery, the same trunnel and peg locking, the same regional wood species. The small number of working dry wood master bridge carpenters in modern America, perhaps 30 to 50 people nationally, mostly work in this restoration tradition. They are trained through apprenticeship programs at the Timber Framers Guild, the Preservation Trades Network, and a few state historic preservation offices. The skill set is preserved, but barely. The next generation of master carpenters is currently being trained on restoration work rather than new construction. The pure wood covered bridge as a working craft is essentially extinct in commercial American construction today, but the restoration craft keeps the technical knowledge alive. Before we close, if this kind of pre-modern engineering story is what you came for, the final boss tier at $9.99 gets you members-only videos plus your name in upcoming uploads. Boss tier at $4.99 for early access. Link in the description. Thanks for watching to the end. 880 covered bridges still stand in the United States today. The Cornish-Windsor Bridge between Vermont and New Hampshire is the longest at 449 feet. The purewood examples are mostly still in service, almost 200 years after the carpenters who built them died. Theodore Burr died in 1822. Ithieltown died in 1844. Louis Wernwag died in 1843. The carpenters, whose names are mostly lost to history, died after them. The bridges they built are still carrying cars across rivers from Vermont to Oregon. The craft has not been recreated at scale anywhere in modern America. The 1,500 original purewood American covered bridges, built between 1805 and 1880 without a single piece of iron, were the high watermark of American medieval timber framing tradition. Most of those bridges are gone now. The ones that survive are mostly still doing what they were built to do. They will probably outlast most of the iron-bolted bridges built to replace them.